Hi, in this video I want us to take a look at a slight variation to the problem we looked at in the previous video. In this problem we turn things around a bit. Still, I expect you to see that essentially the problem remains the same. A small plane is flying directly west with an airspeed of 30 meters per second. It then flies into a region where the wind is blowing at 10 meters per second at an angle of 30 degrees to the south of east. In order to maintain the same direction and speed relative to the ground, the pilot alters both the thrust of the engine and the directional heading of the plane. With what speed and direction must the plane travel relative to the air if it is to maintain the velocity of 30 meters per second due west relative to the ground? As we can see, this problem is similar to the one we looked at in the previous video, only here the pilot ensures that the plane keeps flying at 30 meters per second due west after entering the region in which the wind is blowing. So the problem starts by giving us the speed relative to the ground, 30 meters per second due west. Now note it says airspeed here, so you might think that this is relative to the air, and you would be right. The thing is, however, that you can assume in this portion of the problem that the air isn't moving relative to the ground. So let's suppose someone is walking at 3 miles per hour relative to a walkway, but the walkway isn't moving. Well, in that case, the person would also be moving 3 miles per hour relative to the ground. So even though they say airspeed here, and it's correct, you can also interpret this as being the velocity relative to the ground because the assumption is the air isn't moving. However, afterwards, the pilot enters a region where the wind is, where the air is moving at 10 meters per second and at an angle of 30 degrees south of east. So this now is of course the velocity of the air relative to the ground. So our symbol for that will be this right here, the velocity of the air relative to the ground. So we also know that when the pilot enters the region in which the wind is blowing, his velocity relative to the ground will continue to be 30 meters per second due west. So here's our notation for that velocity, the velocity of the plane relative to the ground. And of course what we were being asked for is then the new speed and directional heading of the plane relative to the air. So this is what we're being asked for. So the first thing you do when you are given a problem is read it carefully and identify the important quantities being described in the problem. Next, you need to establish the relationship between these, and this should not be hard. We know that the velocity of the plane relative to the ground is equal to the velocity of the plane relative to the air plus the velocity of the air relative to the ground. So this is nothing new. What is new is that now we're being asked for this, the velocity of the plane relative to the air. In the previous problems we were given these two and asked for the velocity of the plane relative to the ground after entering that windy area. But now we know that after entering that area in which the wind is blowing, the plane has to keep moving relative to the ground at 30 meters per second and due west. And we know the velocity of the air relative to the ground. So now what we are asked for is the velocity of the plane relative to the air. So basic algebra allows us to then make this the subject of the expression. So we simply transpose this over to this side. Actually, I hate that word transpose. What we do is we subtract this velocity from both sides of the expression. Of course, we can write this the other way around if you prefer. And so what we have here is a vector subtraction. Of course, any subtraction can be represented as an addition. So to subtract this velocity from this one, we simply add the negative of it. So let's take a look at those vectors and see how we do this. Pay attention to this. Notice there's not much different. Right? It's the same quantities, the same relationship. All that we're doing different in this problem is that instead of being given these two and asked for this, we're given these two and asked for this. So you need to develop this skill to be able to look at these problems and recognize that essentially they're the same. All that varies from one problem to the next is maybe what you're precisely asked for, and you need to have the mathematical skill to then be able to get what they're asking for. So here is the velocity relative to the ground of the plane. It continues to fly 30 meters per second due west. Now let's take a look at the velocity of the air relative to the ground. Notice it's 30 degrees south of east. However, we're not going to add these two vectors. The addition of these two vectors would have no physical significance in the context of this problem. What we want is a negative of this. And of course, a negative of this will be a vector of the same magnitude, but in the exactly opposite direction. So there we have it. So this is the velocity we're interested in. So this is the velocity of the plane relative to the ground, and this is the negative of the velocity of the air relative to the ground. So that's the negative of this. And what we want is now the sum of these two. And so this gives us the velocity of the plane relative to the air. So we can put in some notation here. So velocity of the plane relative to the air, velocity of the plane relative to the ground, and that's the negative of the velocity of the air relative to the ground. So that's the negative of this. And so we add these two vectors, and we get this. Of course, you can let GeoGebra do the calculations for us. Remember, you're going to have to learn how to do these calculations. So that's 30 due west, 180 degrees. And now the negative of that velocity is 10,150. And of course, when GeoGebra does the calculation for you, we get that the pilot then needs to increase the thrust of the aircraft. He needs to move relative to the air. His airspeed now needs to be approximately 39 meters per second. And direction is going to need to be approximately 13 degrees north of west. So he has to shift the direction of the plane due north and increase the speed. So I hope you see that the problem is fairly simple. You need to practice a few of them to ensure that you become used to solving problems like these. And also you're going to have to be able to do these calculations. So we'll look at that in the next set of videos. Bye for now.